In contrast to some of the early stuff I did in CS106, where it wasn't a big deal to write 30 lines of code, when you might be able to do sort of lambda calculus in one line, that little efficiencies and kind of ingenious hacks and ways to think about a problem could make a big difference when scaled up to, from one genome to thousands of genomes. And I was really sort of impressed and surprised at just the ingenuity, creativity, and also kind of hard work in math and whatnot that go into scalably sort of computing. When you're dealing with thousands of genomes and running a ton of compute, it was really, really fun to learn.
For the level of projects and the scale of the projects that are existing and the amount of data that we're able to capture today in the bioinformatic world and the medical world. The opportunity to scale using cloud resources is, I learned that, it's critical to be able to maintain the level of care that, we would like to provide to patients.
I learned that you should be able to increase and decrease your use of resources to meet the changing demands of this data set. Of course, the data sets are getting bigger and bigger. And personally, when I was doing my own project and also homework, I ran across barriers in having not enough resources in my local environment or just in the cloud services as well to be able to process all the data. So it was helpful to learn the basics of scaling, such as vertical and horizontal, weak and strong scaling to overcome and speed up these processes, and to know in the future how I would navigate these limits in order to make sure that my data is able to be processed and to be analyzed.
I think these solutions need to be scalable in order to make an impact on patients and to get the most out of the data that you get. I think the reality now is we can collect so much data from individual patients, but most patients we see at the hospital don't get all that data collected on them. And so only through establishing robust scalability pipelines can you expand access to these precision medicine techniques to all the patients that we want to.
For scalability, you understand that with or without the correct setup of your high throughput computing or cloud system, at different scenarios where you have limited time or limited resource, the correct setup scalability is important for efficiency. In my field, where I invested in a lot of biotech companies, time is everything. So as a manager or as a senior leadership, you will be able to explore different technical measures in order to increase the efficiency and really speed up the discovery process.
When it comes to precision medicine and health data, there's massive amounts of data flowing each day for every patient, as well as something like genome sequencing, right? That takes petabytes of data just to sequence a singular patient. And so scaling these applications is super important, and it comes from actually creating applications that can handle this much data, as well as creating applications that can, start to reduce the cost of sequencing and processing the data for these patients.
Yeah, I thought that scalability and security were actually topics that I probably should have thought about a lot more before, but never really fully in-depth thought about. And so being able to learn that there are, even from the basics, very different scalability approaches, like vertical scaling, horizontal scaling, and then thinking about efficiency, cost of scaling, all of those things were not necessarily components that I had really thought about as a student researcher previously. So I thought this would be really helpful as I go forward in my career and have to think about what computational resources I purchase and what's the most optimal types of resources I use. In terms of security and patient privacy, obviously I was familiar with HIPAA and thinking about patient privacy, but I never really fully thought about encryption, how there are multiple types of encryption you can use for different data. I also never really fully thought about how the process of de-identifying data can differ for different types of data. And so thinking about these like very nuanced questions, I think was really helpful.
Also, incredibly important, right? I mean, we always hear about, especially with the rise of, not just in the medical world, but with the rise of AI and big data, social media particularly, there's controversies all the time about data leaks and data protection. So it was interesting to see sort of the various levels of control that a company can have that's, using bioinformatic data. So whether they totally outsource their security to, one of the cloud providers, whether they have kind of a half and half shared responsibility for, who owns the data, what's anonymized when it gets put onto the cloud, or whether they, totally keep it in-house and then they just use services provided by a cloud provider to kind of operate it on data that they are maintaining and protecting themselves. So it's obviously a super important topic, especially with medical data. It's even more sensitive potentially than, other behavioral data that you might be able to collect in other fields about people.
Security obviously is a very important thing that should be constantly reviewed and also make sure that it is being kept, because as a medical student, I always think about like patients' health data and also their chart information, and all those information should be kept extremely confidential. So managing and understanding how to keep your data secure, how to de-identify those information so that people, although they have access to public data sets, cannot identify them to a specific individual is important. And choosing what specific data or the types of data to share with the public is extremely important.
Yeah, so security was interesting because I had sort of come from a background of just where, sort of like PHI is paramount. And that was sort of, we have to protect PHI. That's all we do in healthcare. Not realizing that, the compute itself is pretty valuable and you want to protect, your finite resources against, people trying to mine Bitcoin and you want to make sure that you don't accidentally run up a huge AWS or Google Cloud bill without even realizing it. And so I think, what was great was to sort of broaden my sense of security beyond just protecting PHI.
When you're a researcher or even a care provider, I think you can get these data sets and want to dive into them really quickly and analyze them because that's what you're interested in. You're interested in getting the answer. But I think what this course emphasized was that you need to take a lot of precautions, especially when working with cloud services that are more publicly available or can be accessible by others. You need to take precautions to secure that data, and it's not trivial by any means. And although I'm certainly not an expert on data security, I think this class gave me the tools to know who to reach out to, and it gave a basic overview of the different considerations that we need to take when working with data.
The class introduced about 10 to 20 all different security-related measures that are taken by cloud computing services. Traditionally, in healthcare, it's a field where a lot of data are isolated in different companies, and there's a very slow progression into moving into cloud. Everybody's worried about security, worried about patients' data. However, being able to understand the security measures and investment of these cloud service companies is really helpful, because that would help the entire field to understand maybe the security in the cloud. The data that's in the cloud is actually more secure than the data that's stored locally.
Security is super important. You have governing bodies like HIPAA and the IRB. Those kind of legislations really play a big part in how you have to design precision medicine and cloud computing for healthcare systems. And it's important to learn that from the get-go. I think that a fundamental issue in software engineering and computing in general is that security is usually an afterthought, where if you want to build an application correctly from the beginning, security has to be one of the main pillars from the inception of the application. So I think it's really great the amount of material that we learn relating to security, how to properly secure a cloud application, and how to make sure that everything is HIPAA approved and verified.